Hello everybody. So today we are going to study about a new chapter which is called light. So definitely some of you have studied about light earlier, in which you know something which is called rectilinear propagation of light. Something which is called rectilinear propagation of light. What exactly this rectilinear propagation means? Well, this means that light travels in straight lines. When light travels in straight line, there are certain phenomena that happens. In that, basically we study two phenomena. One is reflection of light. Another is refraction of light. In this too, we have already gone through reflection. Okay, we have already gone through reflection is done. Today we are going to delve into another phenomena of light which is called refraction. So we are going to deal with this one. So a topic slightly changes over here. How? A topic becomes refraction of light. Whenever light travels in straight line, this total field or total topic where light travels in straight line can be called ray optics. Ray optics, okay, it's important. Ray optics. It is also called geometrical optics. It is also called geometrical optics. Okay, so both of these are important. So please underline both of this. So in refraction of light, we need to understand what is refraction of light. Refraction of light is basically, we can say, it is nothing but bending of light. It is bending of light. Yes. Here the light ray bends. So what are we studying over here? What is bending of light? See, suppose here there is a surface. Here there is a surface. And here there is water. Here there is water. So when a light ray falls on it like this, okay, some part of the light ray gets reflected as per the laws of reflection, which we have studied in class 9th. Some part of the light rays gets reflected as per the laws of reflection, that is incident angle, and the refracted angle is also, or reflected angle, is also equal to angle of incidence. Okay. Here this surface of water acts as mirror. Surface of water acts as a mirror or reflecting surface. So suppose the total light rays coming as 100%, out of this maybe around 10% of the light gets reflected. But you know this water is a transparent medium, that is, it allows light to pass through it. So if it allows light to pass through it, definitely a major part of light is going to go inside water. Otherwise the fish and the marine lives will never see light, right? There are many marine lives which are lying below water. So how will they get light? And without light, as we know, sun is the single most source of energy from which we all are getting, or that is the single most cake from which you are getting each piece of it. So that very marine life inside the sea or ocean needs its own bit of cake of that total energy which is provided by the sun. So definitely a lot of amount of light is going to go inside the water level. Okay, so this ray is called refracted ray. So here we can see that there is some bending of light. The light is not passing straight. If you see this light is not passing this way. It is not passing straight. It is bending. And that is why it is called refracted ray. And here there is formation of another angle, which also we denote by R, which is not is equal to I. And this R is angle of refraction. Angle of refraction. So this is another very beautiful phenomena of light which happens when light travels from one medium. So this is medium 1, that is air. Let us take this as air, medium 1, to another medium 2. Whenever light travels from one medium to another medium, there may be bending of light. Why this maybe word is coming? Now coming to it. So here light is traveling from medium 1 to medium 2. Okay. Now when the light is traveling from medium 1 to medium 2, if this two medium is of different, please write this down, different optical density, then only it is going to bend. Medium 1 to medium 2, if there is bending, that means medium 1 and medium 2 does not have same optical density. Now the question is, what is optical density? Very often this optical density is equated with density of medium. Absolutely not true. Optical density is not density of the medium. Optical density is not density of the medium. Like for example, oil, density of oil is less than density of water. We all know that. but optical density of oil is more than optical density of water. Okay, so how this optical density is defined? Okay, let us go one by one. Things are very easy, very nice, and everybody will understand these things with ease. I can guarantee that when you read and write along with me, which is very important in any sort of educational purpose or anything you do in life, you have to read and write, then only you will excel. Okay, so I hope you guys are doing that. So now we are going to understand what is optical density, right? So optical density basically is decided or signified by speed of light in that medium. That is what optical density is. It's very simple. Then how does this really affect? Suppose there is medium 1, there is medium 2. The speed of light, speed of normally you know that speed of light is denoted by c is equal to 3 into 10 to the power 8 meter per second, but this is only valid for air or vacuum. Okay, that is what it is. Now if in medium 1 it is v1 and if in medium 2 it is v2, and if suppose the speed of the light in medium 1 is more than the speed of light in medium 2, then optical density, which I will denote as rho O, maybe rho O1, and this will be rho O2. Optical density of medium 2 will be more than optical density of medium 1. Reason is very simple. Whenever the speed is increasing, optical density will decrease. If the speed increases, optical density will be lesser. Okay, so whenever the speed, now please write this down very carefully. Suppose speed of light in medium 1 is more than speed of light in medium 2. That means which is more optically denser? Wherever the speed is less, it is optically denser. So here, from here I can say medium 2 is optically denser. Medium 2 is optically denser. Medium 1 can be called as optically rarer. Okay, so let us first analyze this one. Okay, one by one we are going to analyze. So let us first analyze this one. Okay, so here there is a transparent medium. Both are transparent. This is medium 1, this is medium 2, and definitely this is incident ray. This is called point of incidence. This is called point of incidence. Wherever there is point of incidence, we have to draw a normal, and the normal will always be at 90 degree with the refracting surface. So refracting surface or interface between two medium, or interface between two medium. So now what I am going to do, I am going to draw a normal, okay, and I am going to extend this like this. So after this is basically angle of incidence. Whenever the light is going from optically rarer medium, this is rarer medium, this is denser medium. Whenever the light is going from rarer medium to denser medium, it bends towards the normal. It bends towards the normal. Okay. So here is formation of your R, and we all know that R is angle of refraction. You can write this down. I is equal to angle of incidence. I is equal to angle of incidence. R is equal to angle of refraction. All okay, I guess everybody understood up to this. So whenever there is a light coming from rarer to denser medium, its speed decreases. Its speed decreases. So here definitely speed of light in medium 1 is more than speed of light in medium 2. And due to this decrease of speed, light bends towards normal. Okay? Due to this decrease of speed, light bends towards the normal. Okay, and in this case definitely you can write down that angle of incidence is more than angle of refraction. Okay, this can be written. So this is when the light is from rarer medium to denser medium. Opposite side, say from rarer to denser, let's do this. From rarer to denser medium. Okay. No, this was from rarer to denser already. So this should be from denser to rarer. Okay. So this is the light that is coming. Here is my normal. This is my angle of incidence. Then where will be my refracted ray? My refracted ray is going away from the normal. My refracted ray is going away from the normal. So whenever it is going from denser to rarer medium, that is, this is denser and this is rarer, then what all are happening? Let's write this down one by one. First of all, light bends away from normal. This is first. Number 2, light speed increases. That is, V2 is more than V1. Tick. Number 3, angle of refraction is more than angle of incidence. So these are the 3 things that are happening when there is a light which is going from denser to rarer medium. Please note, do not forget this. I have already explained. Whenever light hits a transparent medium, light not only reflects, light also refracts. So here is a case where there is partially reflected and partially refracted. Okay, so there is partial reflection and partial refraction both happening. However, as we are dealing with the chapter of refraction, we are showing here only refraction. So that is what is my intention to again show you that. Okay, and to also you need to keep your notes in a proper fashion so that you don't miss anything. That's what our intention is. Okay. So what is basically refraction? Refraction is change in direction of path of light. What is refraction? Let us write this down. Change in direction of path of light when it passes from one transparent medium to another, from one transparent medium to another. Okay, is called refraction. Okay, so this is the definition of refraction. Now we are going to understand something that is called angle of deviation. Which is also denoted by del. Also denoted by del. So what is angle of deviation? Let's understand this. It's a very easy thing. So if a light is hitting like this, suppose it's bending away from normal, this is my normal, this is my angle of incidence, this is my angle of refraction. If there was no change in medium, so definitely this line would have passed like this, but that didn't happen. Then if this line would have passed like this, please notice this line, if this line would have passed like this, then if you consider this as a line and this as a line, two intersecting lines will have vertically opposite angles, this as I. So there is a change in angle, right? And that changes this one. Now the total angle is, if you see, this is the total angle, right? That is R, and this part is I, which is vertically opposite with this one. So this one will be the change in angle, which is called angle of deviation, which is the amount the ray has deviated from its original path. So this will be here R minus I. Okay. Now if we take, this was from denser to rarer medium. If we take a medium which is rarer and the light is traveling from rarer to denser medium, then light would have bent towards the normal. Okay. Now if this ray would have gone like this, then would it be like this? Okay, it would have been like this. So this total angle was equal to this angle, which was I, and this part we can call it as R. Okay, so here is the deviation over here, and the deviation would have been total angle, that is I minus R. So this is angle of deviation. This will happen when the light ray is bending. Is there any chance when there will be no angle of deviation? Yes, there can be. Angle of deviation 0. Angle of deviation 0. What are the possibilities of this? There are two possibilities. Number one, if the velocity in medium 1 is equal to velocity in medium 2, which is the case, optical density of medium 1 and 2 is same. So there can be a case like this. There can be a case like this. And then what is the other case? Other case is when angle of incidence is 0. This is also called as normal incidence. What do you mean by that? What do you mean by that? Normal incidence. Many a time students make a mistake. They think normal incidence means angle of incidence is 90 degree. No. If this is your normal and if the incident angle is falling at 90 degree to the surface of the refracting surface, then the refracted ray will go like this. So here angle of incidence is 0 degree, because angle of incidence is defined as the angle between incident ray and the normal. So that is basically over here non-existent. So that is 0 degree. So that is why the angle of incidence will be 0 degree, although it will be called as normal incidence. Okay. So I guess we have all understood the parts that are important over here. If it is asked what is the cause of refraction, that also we have done. It is due to the change of speed of light in two mediums. It is due to the change of speed of light when a light is traveling from one medium to another. Then it is basically the reason for bending of light. It is basically the reason for bending of light. Okay. Now we are going to study about laws of refraction. We are going to study about laws of refraction. So what is laws of refraction? So as you have studied in reflection chapter in class 9, same is over here also. There is not much of a difference. The first part is absolutely same. What is it? Incident ray, refracted ray and the normal. Incident ray, refracted ray and the normal at the point of incidence all lie in the same plane. All lie in the same plane. Next, this is new. This is the ratio of sine of angle of incidence. So you must have studied a bit of trigonometry. Two, sine of angle of refraction is constant for a pair of given medium. Okay, so both these laws are basically given by a scientist named Snell. So these are also called Snell's law. Snell's law. Okay, and this is basically can be written mathematically as sine I, that is angle of incidence, divided by sine r, which is equal to a constant, It is called refractive index. This symbol, I'll just explain it to you completely. This symbol is named as mu. This is named as mu. Okay, you just pronounce that mu. Sometimes it is said as MEW. I'll say that mu. That is okay for us, right? So this is 1 to 2 means that is medium 1 to medium 2. I'll just explain the complete stuff to you. So there is no confusion at all. Okay, there should not be any confusion in this. Okay, suppose this is bending away from the normal. Now this is my normal. Okay, this is my normal. Okay, so this is my angle of incidence, this is my angle of refraction, this is my medium 1, this is my medium 2. So sine I by sine r is basically from medium 1 it is going to medium 2. Arrows are very important because if you do not give arrow in ray optics or geometrical optics, your marks will be deducted, but tremendously. It should be given 0 actually. So if we are writing sine I, that means this incident angle is lying in medium number 1, and when we are writing sine r, this is lying in medium number 2. So 1 mu 2. This is called refractive index. This is called refractive index, and refractive index is defined basically based on which medium the light is going and from which medium it is coming. So it is refractive index of medium 2 with respect to medium 1. This is very important line. Medium 2 with respect to medium 1 is called refractive index. We are going to go in deep into the refractive index. Now what is refractive index? Refractive index can be defined as sine of angle of incidence by sine of angle of refraction. That is okay. It can also be defined like this. Suppose this is 1 mu 2 can be defined as speed of light in medium 1 divided by speed of light in medium 2. Okay, now suppose, so this is also equal to, you can write sine I by sine r. Okay, now if suppose the velocity over here is v1 and here it is v2, so it can be written as v1 by v2. Now if a light is going from medium air to medium water, then this formula will be velocity of light in air by velocity of light in water. So generally all the refractive index values have been tabulated with respect to air. So this is very often called as absolute refractive index. Absolute refractive index. Absolute refractive index is basically refractive index of with respect to air or vacuum. Okay, that is air or vacuum. That is absolute refractive index. Done? I think everybody have understood all these things. Okay. So normally if you see absolute refractive index for any medium can be written as C by V of that medium. Correct? Now, this C is basically constant. This C is basically constant. So I can write this as K by V. And from here you can also write is inversely proportional to Vm. Okay? It is inversely proportional to Vm. Now what is this Vm? Velocity of light in that medium. That can be denoted as frequency into wavelength. So we can write this frequency into wavelength. Now this frequency part, this frequency only depends on source, only depends on source of light, not on medium. Source of light, okay, not on medium. So very important, doesn't change in refraction. Frequency doesn't change in refraction. It's a very important part. Please mark it. Whatever you want to do, please do that. I would suggest, please do that. Whatever you want to do, please do that. Okay. So from here I can say that refractive index of any medium is inversely proportional to only wavelength. Very, very important. Very, very important. You need to do this with a lot of diligence. Whatever is taught in the last few minutes. Very important. Okay. So I hope everybody is getting what we are trying to study at this point of time. Any comments, any queries, please write down in the comment section so that we can address it. Okay, please write down in the comment section. If you have understood it, please write down you have understood it. If you have not understood it, wherever there is a problem, please write down in the comment section so that we can deal with it. Okay, next part. Now just now we have learnt that. Just now we have learned what all we have learned. Let's see, let's tabulate. We have learned medium 1 to medium 2 refractive index is velocity in medium 1 divided by velocity in medium 2. It is also is equal to sine of angle of incidence by sine of angle of refraction. Next, what we have learned? We have learned that if we compare it with air, then it is C by basically velocity of light in that medium. We have learned that A mu m is inversely proportional to lambda of that light in that medium. So wavelength changes. So see, if I ask you, if I do a little bit of calculation over here, then if it is A mu say n, then it will be inversely proportional to lambda n. Correct? Inversely proportional to lambda n. Correct or not? Correct? Okay. So if suppose I want to find out what is m mu n, how do I go about it? I go by the first principle, that is 1 mu 2 is v1 by v2, so this will be vm by vn. It will be vm by vn, and vm by vn I know there is no change in frequency, so this will be lambda m by lambda n. Correct? It will be lambda m by lambda n. And how can we relate with this right now? See, a mu m is inversely proportional to lambda m. So if lambda m is on the numerator, a mu m will be in the denominator, a mu n will be in the numerator. Just the opposite. So you can easily calculate any refractive index, any relative refractive index from its absolute refractive index. First, you have to write the absolute refractive index of the medium where the light is going. Then you have to write the absolute refractive index of the medium from where the light is coming, and that is why it is called refractive index of NC with respect to m. That is why m is coming in the denominator. Okay, I hope you have understood it. Why not do a simple problem? Right? Let us take this one. A mu glass is 3 by 2. A mu water is 4 by 3. Let us find out what is G mu W. It is refractive index of water with respect to glass. So it will be A mu W by A mu glass. So this will be 4 by 3 divided by 3 by 2. So this will be 4 by 3 into 2 by 3. So this will be 8 by 9. If it was asked that W mu glass, please find out. Then glass with respect to water. So A mu glass by A mu water. A mu glass by A mu water. Okay. So how will I find this out? A mu glass and by A mu water. How will I find this out? A mu glass is 3 by 2 divided by 4 by 3. So that will be 3 by 2 into 3 by 4. So that will be 9 by 8. So from here I can also say that if it is 1 mu 2, that is 1 by 2 mu 1. Correct? Understood this thing? Dimag ka batti jala? So light is very interesting. Lot of short calculations are there. I will not burden you guys with lot of stuffs in one day because it is an online class. I understand in online classes the amount of content should not be delivered in too much heaviness. It should be delivered in short bursts, what I feel, what I have understood in my teaching profession. So you first go through this. You just go through the notes, practice the notes time and time again. That will be more than enough. And after that, we are definitely going to delve a little bit more into this. In this, the where we have ended, the last 15 minutes, when we start the next class, we'll cover this last 15 minutes and then we'll go ahead. So there is no hurry. If you are going to do a little bit fast, it may create troubles. So I don't want any troubles, neither I think you guys want any troubles. So it will be completed with cool life. Thank you very much to my guys and girls.